Good morning. This is Harshavardhini, Assistant Professor from Department of IT, Wheeltech Multitech. Now we are going to see a topic on Internet of Things, that is IoT architecture. We all know that IoT, that is Internet of Things, which refers to the collective network of connected devices and the technology that facilitates communication between devices and cloud, as well as the communication among those devices. Some real-time examples of IoT includes smart appliance, connected cars, and security system and healthcare monitors. And now coming to the topic, which is OSI reference model. This OSI reference model consists of 7 layers, which starts from basic physical layer to application layer. The bottommost layer is physical layer, which transmits the raw bit stream over the physical medium, and the second one is data link layer. This defines the format of data on the network, and third is the network layer. This network layer provides the physical path that the data will take, and the fourth is transport layer. This transport layer uses TCP and UDP for data transmission with the help of transmission protocols. Fifth is session layer, which maintains the connections, that is responsible for controlling the ports and sessions. Sixth is presentation, and seventh is application layer. This presentation layer is mainly used for data encryption purpose. And seventh is application layer. This layer works as HCI, that is human computer interaction, where the applications can access the network services. Next is IEFT architecture. So there are multiple architectures in IoT, that is like IEFT, ITU, and basic reference model architecture like that. The first one is IETF architecture. This IETF architecture consists of three main working groups. One is 6 low pan, that is 6 refers to IPv6 over low power WPAN, and second is core, that is constrained RESTful environment, and third one is role, that is routing over low power and lossy network. This is the architecture of IETF working group. So here this architecture consists of four main divisions. One is modified OSI stack, which comes from the OSI reference model. And second one is 6 low WPAN, that is IPv6 over low power WPAN, and the last two is core specification and role specification. So in modified OSI stack, you'll be having 6 different layers. That is, the combination of physical and data link layer will be combined as a single layer. Second one is adaptation. Third one is network. Fourth is transport. Fifth is application support, and sixth one is application. Then next is your IPv6 over low power WPAN. Here it consists of multiple protocols, that is IPv6, 6 low, that is IPv6 low power WPAN, and 802.115.4 and BLE and DECT-LE. So these are all the protocols which comes under the WPAN specification. And second and the third is UDP protocol, user defined protocol, and next is COAP and role. This is this the COAP, UDP, and role combines of both core specifications and role specification. So this is also called as a RESTful representational state transfer architecture, where it works under the set of guidelines which provides the best practices for building a distributed hypermedia system. Next is IETF architecture. So this architecture provides specifications which makes to address different part of the communication stack over the constrained devices. So here all the IoT here all the devices layers and OSI models are merged into a single IoT. It consists of a application support layer, which where the presentation and the session layers are combined, and it has an adaptation layer. In this adaptation layer, it is positioned between the physical data link and the network layer. Next one is IETF architecture for IoT. So this architecture works under several core workgroup draft specifications. So first one, this draft specification, this describes the transport and application support layers, which essentially defines the transport packets, formats, and for it ensures the reliability support. It some of the main features of COAP is constrained web protocol, which has M2M requirements. Next is binding of UDP with optional reliability support. It also supports unicast and multicast request. And third is asynchronous message exchanging, so we can exchange the asynchronous messages. And next is URI and content type support, which works on low header overhead and passing complexity. And last one is simple proxy and caching capability. So next, this IEFT architecture for IoT works on core link format. This format is used to specify or describe a discovery method for COAP resources based on the COAP server. This core link format is carried as a payload, and it is assigned on an internet media type. Here we are using a well-known URI, which is called as well-known/core. It is defined as the default entry point for requesting the list of links, and also it provides the resources hosted by the server by performing the core resource discovery. Here, the core interface specification, which describes the interface types and corresponding expected behavior of RESTful methods. So this method is mainly used on drafting a specification for a resource directory. So here, a resource directory in COAP is a server resource which is defined by /rd that maintains a list of resources, their corresponding server contact information, that is their IP address, domain, and all, and which is similar to core link formats. Next is this architecture also comprises of IPv6 over low power wireless PAN, that is personal area networks. So this allows in this network there are IPv6 packets which is used to carry the data efficiently within the small link layer frames. And next is it has own encapsulation and header compression mechanisms. So by using these two mechanism, it enables the IPv6 packets to be sent and received over IEEE 802 based networks. Some of the requirements for low PANR device properties, link properties, network character, security, and mesh under forwarding. This device properties consist of low routing state and minimal power consumption. Link properties, which is used in minimal routing overhead, and network characteristics. So this network characteristics may be periodically hibernate. And the security, so it ensures the confidentiality and the authentication of the data that is to be shared. And last is the mesh under forwarding, so which is the MAC address. Next is IPv6. So this IPv6, it is the Internet Protocol version 6. It acts as the communication protocol which provides an identification and location system for computers on network, and it routes traffic across the internet. So this IPv6 was drafted basically in 1998, and it came as an internet standard in 2017. This IPv6 can be dealt with long anticipated problem for which comes under IPv4, that is address exhaustion, that could be replaced under IPv6. So the size of IPv4 address is 32 bits, which provides an addressing capability of 2 power 32, that is 4.3 billion addresses. The size of IPv6 is 128 bits, which is the address space of 2 power 128. Next is ITU-T architecture. This architecture is also comes under the IoT. This architecture is mainly this architecture or this ITU model is mainly used to bridge the standardization gap. So it has following layers: application layer, service and application support layer, network layer, and device layer. The bottommost layer is device layer, which performs device capabilities and gateway capabilities. Next is the network layer. This layer performs two operations. One is to analyze the network and to provide the transportation of data through the network. Next is service and application support layer. So this provides generic support capabilities and also some specific supports that is required for an ITU to transmit the data. And last one is the application layer, which works on IoT applications. And this ITU-T architecture can also be used to manage capabilities like generic management capability and specific management capability, security capabilities, etc. So now in brief, this ITUT, that is IoT domain model, it includes the set of physical devices which connects directly through the gateway device to the communication network, which allows them to exchange the information from other devices, services and applications. So in order to capture and transport the information about the things, these devices include a mandatory communication capability, which includes optional sensing, acquisition, and processing capabilities. So, regarding these service capabilities, the application layer considers as the host of specific IoT applications like hosting remote patient monitoring, data sensing, weather monitoring, etc. So this service and application support layer, which is otherwise called as service support and application support layer, this consists of generic service capabilities, which is used by all IoT applications like data processing and storage, some specific service capabilities, which is tailored to specific applications like e-health, telematics, etc. So in this architecture, there is a network layer which provides networking capabilities like mobility management, authentication, authorization, and accounting, which is shortly defined as AAA, that is authentication, authorization, and accounting. So these functions are used in ITOT architecture for connecting the service data. This device layer, it includes device capabilities and gateway capabilities. So this device capabilities include direct device interaction with the communication network, and the gateway device capabilities include multiple protocol support and protocol conversion, which is used to bridge the network layer capabilities and the device communication capabilities. Next one, the management capability. So in management capability, there are typical FC, it is called as FCAPS, that is Fault Configuration Accounting Performance and Security Model. So this model is mainly used in device management for provisioning of software updates, activation, deactivation, and all. And also there has network topology management, so which is used to identify the short and local range networks. And last one is the traffic management. So based on service capabilities, so this layer represents the grouping of different security capability required by other layer. These capabilities are grouped generically like AAA, and this integrity is and the integrity and confidentiality is maintained to the highermost safety, where it can be grouped specifically that some specific applications like mobile payment and all can be managed here. Next one, architecture reference model. So this reference model is used in IoT. So we all know that IoT is something. It is a connection or way of interacting with the devices. So here we are using NAT, that is network address translation. So by using this, billions of devices can be connected, and they are highly available, which supports deployment across the data centers to allow disaster recovery. So this device may not have UI, that is user interface, and certainly designed to everyday usage, so we need to support some automatic managed updates. And here we'll be using some remotely managed devices. This IoT is very much common in analyzing the personal data. This is the architecture of reference model. The architecture of reference model is combined under two types. One is reference model and reference architecture. This reference model it consists of four IoT architecture systems. One is IoT domain model, second is information model, third one is functional model, and last one is communicational model. This IoT reference model aims by establishing a common grounding and also a common language for IoT architecture and system. Next is IoT reference model. So in this model, it acts as a communication tool for different stakeholders of the system. So where the developers, the component, and the system managers and all will have different views of a single system based on their requirement and their specific interactions with the system. So this model uses the domain by using multiple submodels. So this multiple submodels include, so see, there is a main IoT domain model which consists of multiple submodels like IoT information model and IoT functional model. This IoT informational model is used to handle the informations, and IoT functional model consists of common functions and some secondary functions. This is the main architecture. So from reference to concrete architecture, this is the actual system here. The reference architecture consists of, see, the reference architecture consists of multiple sub-architectures where it is used to extract the essentials and it is sent to the concrete architecture. In this concrete architecture, we will be designing, engineering, building and testing the components, and we'll be sending them to actual systems. And the actual systems consist of this actual system consists of internet analysis and all. So once after analyzing all the builded model, they will be providing feedback, constraints, and some of the opportunities that could be clarified in later. So this is the reference model. Thank you.